Hello students, good morning. Today we discuss about the inverse of matrix using the determinants. Previously we discussed about the adjoint and as well as introduction of determinants, minors and cofactors and properties of determinants. Now today this is first of all a square matrix A has inverse if and only if the determinant of A is not equal to 0. To explain this determinant of A is not equal to 0, this singular matrix we first of all define a square matrix A has to be singular if the determinant is 0. And if it is not equal to 0, then it is a non-singular matrix. Here, the inverse of A inverse of any matrix is equal to adjoint A in the numerator and in the denominator of determinant of A. Of course, this determinant of A is never equal to 0 because if it is 0, then it is undefined. So the properties of the inverse matrix is AB inverse multiplication product is equal to B inverse into A inverse. And second one is the inverse of any matrix inverse is equal to A. And any transpose of A of its inverse is equal to inverse of A matrix and its transpose. So this is the properties of the determinants and the definition of A inverse and singular and non-singular matrix. Here let A is equal to this determinants, this matrix 2, 3, 1, minus 4. Of course it's the determinants because it's a square matrix, and B is also matrix 1, minus 2 and minus 1, 3. This is also the square matrix, and verify that the product of both matrices inverse is equal to B inverse into A inverse. That is the one of the property of the inverse matrix. First of all, I discuss the left hand side. In the left hand side, we are taken the product of the two matrices, and that is equal to yes 2, 3, 1 minus 4 and 1 minus 2 minus 1, 3. When we solve, this is equal to 2 minus 3 and minus 4 plus 9. This is 1 into 1 minus 4 into minus 1 is 4. This 1 into minus 2 is minus 2, and this minus 4 into 3 is minus 12. So that is minus 1, 5, 5 and minus 14. So this is minus 1, 5, 5 minus 14. Here the value of determinants, because we know that the inverse function, the determinant is also required. So this is AB is equal to the determinants, that is equal to, we already find out minus 5, minus 1 and 5 and 5 and minus 14. And that is equal to 14 and minus 25 is equal to minus 11. So this determinants of the value is minus 11. Now we find the inverse of AB inverse. This AB inverse is equal to, that's we have to find the adjoint A B upon determinants of AB. Now lot of questions we already solved in the previous videos. I will solve this directly, the adjoint AB. This adjoint AB is equal to your this A11 means your first one is your minus 14, and this A12 is also equal to -5, and his A21 is also equal to -5, and his, of course, A22 is also equal to -1, upon that is equal to -11. So 14, 5, 5, 1 is upon 11 is my first equation. If we wish, I can explain this. A11 is equal to -14. First row and his first column is, we can leave it and remains only -14. After that, in the A12, the value is negative because we already discussed -1, 1 plus 2. And therefore, it is written as yours. This is this and this, and that is equal to -14, and this is equal to -5. Then A21 is again minus this first one, and this one is again -1. And therefore this 5, and therefore it is -1. So all the values are negative, and here divided by -11, then it becomes to equal to this much. For B inverse, the right hand side, I first of all find the determinants of B. Means 1 minus 2 minus 1 3 is equal to 3 minus 2 is plus 1. The code adjoint is B11 is equal to, yes, 1 and 1 is 3. B12 is equal to this and this equal to plus 1. B21 is equal to second row and first column, that is equal to 2. And B22 is equal to second row, second column, and remaining element is 1. So B inverse is equal to adjoint B upon determinants of B, that is equal to 3, 1, 2, 1, and divided by 1 the value of the determinants. Now for this A, for A inverse, that is equal to, your determinants of A is equal to, we have to take in 2, 3 and 1 minus 4, and therefore it is written as -8 minus 3 is -11. Then the adjoint of A11 is equal to -4. The adjoint of A12 is -1. The adjoint of A21 is equal to -3. And adjoint is A22 is equal to 2. So the A inverse is equal to adjoint A and divided by the determinants of A, therefore -4, -1, -3 and 2, and upon of -11. Now we find the value of B inverse A inverse. The value of B inverse A inverse, that is equal to this B value is 3 upon 2, 1 and 1. And A inverse value is -4, -3, -1 and 2. And this is upon -11. When we simplify and get the value of -12 plus 2 -2, this is -9 and plus 4, that is 1, and by 4 is -4 and -1. This 1 is multiplied with -4 and -1. This 3 is multiplied with -4 and -1. and this 3 is multiplied with minus 9 and 2 is multiplied with this 4, and that is equal to minus 9 plus 2 upon 1 upon 11, and that is equal to minus 14, minus 5, minus 5 and minus 1 upon minus 11. So this B inverse A inverse is equal to, we are taken here 14, 5, 5 and 1 upon 11. Now this is my equation number 2. From equation 1, AB inverse is equal to, we already solved this one, this is equal to 1 upon 11, 14, 5, 5 and 1, and therefore left hand side and right hand side are equal from equation 1 and 2. Now this is the complete of my question, and students will discuss about the next topic and the inverse of this matrix application.